Hello guys, this is Wits Lounge, learning made easy. And in today's class, we are going to be understanding a very important concept known as Iupac nomenclature of amines. Before we get into the study, hit that subscribe button. You know what it is. Don't forget to like and also share. So let's get into it. First of all, I would like to say that amine is a derivative of ammonia, as we studied in the earlier video. So whenever you're talking about an amine, it is actually produced when you replace the hydrogen atoms in ammonia by aryl and alkyl groups. But that's not the emphasis in this study. In this study, we are going to be considering how to name these particular amines. Okay, so let's get into it. We'll be considering some important rules, which include, starting from the first one. The first rule says if an amine group is attached to a benzene ring, it is referred to as aniline. Very simple. And what does that mean? First of all, you should know what the benzene ring is. And the benzene ring is simply that hexagonal structure or cyclic structure with the ring at the center. It's your aromatic hydrocarbon, characteristic aromatic hydrocarbon, from which others are derived. Okay, so once you have that particular benzene ring and attach an amine, automatically this is what we refer to as aniline. Aniline can also be referred to as phenylamine, but in most cases it is preferably referred to as an aniline. So what does this mean? It simply means that if I attach a methyl group here and I'm to name this is going to be 3-methyl aniline. I've discussed how to name your aromatic hydrocarbons or aromatic groups, so please look up that video. The link to it will be found in the description of this particular study. Okay, so let's get into it. Moving ahead from this particular first rule, we'll go to the very next rule. And what does that next rule say? It says that when naming alkyl amines, the longest continuous chain of carbon atoms attached to the nitrogen atom becomes the parent chain. So what does that mean? If you have a particular group or chain where there are variable alkyl groups, such as, so if you look at the structure on the screen, we have maybe like CH3 attached to nitrogen, and then on the other end you have 1, 2, 3 CH2, CH2, CH3. Then probably there's like a hydrogen atom here. So notice something. This side has 3 carbon atoms. This particular alkyl group is just 1, which means that according to this rule, this side with the longer chain will be attached to nitrogen and become the parent chain. So this is the parent chain. And if this is the parent chain, the implication is that we are going to be naming it. How do we name this parent chain? Very easy. The parent chain is simply named by replacing the E in a corresponding alkane by the suffix amine, which is amine. So if we want to name the parent chain, we just replace the E in corresponding alkane with amine. So let's look at this. What is the name of this compound when you are considering this as an alkane? There are 3 carbon atoms, which is propane. 3 is prop. So once you have that propane, instead of having the E, we replace this E with amine because of the attachment to nitrogen. So automatically it becomes propan. Instead of the E, we have amine. Now note, if there are if there's a different position for this amine, take for instance you have that it's like C C C C C and the amine is like located here, you would have to indicate the locant of this amine basically. Okay, so let's move ahead of that to the next rule. Okay, having said that, the very next rule, which is rule number 3, states that we should allocate locants to the carbon atoms of the parent chain starting from the end closest to the functional group of highest priority. Yes, this is actually a general principle in naming, that you actually start from the ends closest to the functional group of highest priority. Now if you just have amines, it means that you should start from the end closest to amines basically. So let's check that out. Okay, so imagine we are considering this particular structure. Okay, let's start with the first one. We can number from here because this is far from the amine. The amine is this nitrogen basically. So we have that. If we are numbering, we have to number from this end. 1, 2, 3, and that's that. But in the case of this particular structure, we'll have to number from this side because it's closer to amine than this guy. So that's going to be 1, 2, 3, 4, 5. Imagine you have a different structure, something like this, and then probably you had NH2, and then probably you had like OH. You will notice something in the order of priority. Amine is not higher than OH, so which means OH will take precedence here, which means you are going to number from this side. Why? Because OH has a higher precedence or priority to amine But in the case where OH is not around or any other higher functional group is not around, we're going to consider amine as the highest. So that's why we had to name from this or number from this particular side. So if we number, we have 1, 2, 3, 4, 5, and if we had to name this particular compound, it is now going to be 5 is pent. So that's going to be pentan. What number are you looking at the amine at? 2 amine. Basically that. If it was on number 3, pentan 3 amine. If it was on number 4, it can be on number 4, because when it's on number 4, you have to count from this end. Okay, so we have that about how to name or allocate locants to an amine. With that said, we'll go to the next principle. And what is the next principle? The other alkyl or aryl groups attached to nitrogen are named as prefixes to the parent name, with its locant as N. So imagine, for instance, we have this structure explaining what we just said. If you consider this structure, you notice that there's an alkyl group here, and this alkyl group has to be referred to as a substituent. So let's name this all together. The parent name is propanamine, and they said that we have to name this as a prefix to the parent's name, and the prefix, this is methyl, so we have to put that methyl. However, it is important that you note the locant. It is attached to nitrogen, which means it's going to be N-methyl propanamine. Okay, let's consider a different structure. Take, for instance, you have something like this: CH3 attached to N, attached to C2H5, attached to C4H9. So how do we tend to name this particular compound? Very easy. Now, the longest chain here is this guy, which means that our parent chain obviously has to be from this end. Basically, that's the first thing. So naming this is butane, so this is going to be butanamine. Okay, now you have two substituents to nitrogen. The first substituent is methyl. The second substituent is, this is methyl. The second one is ethyl. Now remember that in naming, you are supposed to arrange it alphabetically, basically. So if we are going to name, we'll start from E before we go to M. Now remember, their substituents would be N. So if we're going to name this compound, it's going to be N-ethyl. Why is it N-ethyl? Because ethyl is attached to N. N-ethyl, then we have another substituent methyl, which is attached to N. So it's going to be N-ethyl, N-methyl, butanamine. And that's that basically on how to name it. If you had, for instance, CH3 attached to nitrogen, attached to C2H5, and probably another CH3. If you are going to name this thing down, it's going to be, you have two methyl groups attached to N, so it's going to be, naming this particular compound is going to be N, N dimethyl ethanamine. So that's that basically about naming it. The general principles or earlier studies on naming, the link would actually be posted in this video, so make sure you look it up, because as I said, we are emphasizing on the principles in naming amine. The rest of the principles of naming other organic compounds, which is the foundational study on Iupac nomenclature for organic compounds, I will post the link on the description, so please look it up for you to be able to easily understand these things that we are doing. Okay, so having said that, we have gotten that particular principle off the table and have to mention one final thing. The general principles in naming amines or naming other organic compounds, as discussed earlier, also applies here. So your principles of alphabetical order arrangement and your principles of order of priority and the rest of them, these principles are expected to be applied in this case. We are going to try to name one particular compound finally, and then we'll call it off on this study. Okay guys, we are going to be naming this particular structure, and this is the structure of dopamine. I presume you all should know that this is the hormone that is produced to help us feel pleasure, and satisfaction, like reward. Whenever we get something done correctly, that feeling you have of, this is me doing this. The dopamine is what is responsible. So we are going to have dopamine secreted in our head because we'll be able to name these things more correctly. Okay, now the first thing I would like to say is that once you have a functional group of higher priority than amine. The implication is that wherever that functional group is found would become the major or parent chain. You get? So in this case now, you will notice that OH has a higher priority to amine. I've discussed this in an earlier video, so please look it up. And because OH has a higher priority to amine, automatically is we are going to be considering the OH as the parent chain, and this amine end as the substituent. Now, when amine is considered as a substituent, it's important to note that it is referred to as amino. It is written as a prefix as amino, and you would need to indicate the position of the amine in the carbon atom. Basically, we will get to understand this thing. So let's get to it. Now, the first thing is we have to name our parent chain. Why we chose OH as the parent chain is because OH has higher priority or precedence to amine. So where OH is found becomes the place of major priority. That's why the parent chain is going to be this benzene ring, and that's going to be 1. We have 1, 2, 3, 4, 5, and 6. You name it or number it in such a way that you will have lower numbers attached to the different substituents in this particular thing. So the parent name is going to be benzene 1, 2 diol. That's the name of this particular parent name. Now let's consider the ring. Okay. Now let's consider the substituent. The amine substituent is more or less ethylamine, and it is attached to number 4. But you will notice that the number, yes, why is it ethylamine? Because you have every junction in a particular skeletal structure represents a carbon atom. So you have one carbon atom here and one carbon atom. Two carbon atoms are ethyl attached to amine. If we are to allocate locants to this particular ethyl group, the locants are going to start from this end because it is closer to the major functional group of higher priority. So it's going to be 1 and 2. So which means that this amine is on the second carbon atom. If we are going to name this substituent, it will now be 2-amino ethyl. 2-amino ethyl. That is to say, the amine group is attached to the second carbon atom of the ethyl substituent to the parent chain. So remember, this particular ethyl group or ethyl amino group or amino ethyl group is attached to carbon number 4 in the parent chain. As I said, this is the substituent, while this other part is the parent chain. Why is this part the parent chain? It's the parent chain because it has the functional group of higher priority in it, so that's why it's the parent chain. So this is the parent chain. So we've named the parent chain as benzene 1,2-diol, and we were able to come up with the name of the substituent as 2-amino ethyl. Now what we need to do is to put them together. Now putting them together, we are going to have that the name of this compound is 2-amino ethyl benzene 1,2-diol. Now however, it's important to note the position of these 2-amino ethyl. It is on carbon number 4, so we need to like put all these guys in a bracket because all of them, the 2-amino ethyl is attached to carbon number 4. So that's why we have this as the basic name. So the name of this compound is going to be 4-2-amino ethyl bracket close benzene 1,2-diol, and that is the Iupac name of dopamine. I presume this video has been helpful. Remember, this is Wits Lounge, learning made easy.